Today we will be making real artificial intelligence using wires in shapes. This is a nice little factory builder. Every level we get a new shape which we need to deliver in order to progress to the next level. I dare say we have mastered the basics of the game and even the advanced mechanics. The only thing left is proper automation. We are in the end game now. The current state of the game is this. We get generated a random shape and we need to deliver it. However, ideally, we do not want to alter our factory after we receive the shape, which means we need to reach full automation. This means creating a huge factory that's fully automated and capable of creating any shape possible. The factory is going to have many parts, and one essential part is going to be a universal paint mixer. We've created something like that last time already, but it doesn't look pretty. Its inputs are these three buttons, which give it an RGB combination of colors. But that's not exactly what we need. We need full automation. So that's what we're gonna be doing today. Now, unlike before, we need to get that paint information automatically. So here we have a constant signal and we can set it to the current goal shape. The shape information is carried by this wire. This here is just a simple example, but I have unstacked the shape. So you can see that there's white star and on top of that there's purple star. So here we have the purple star information. And now we need to analyze it and know that it's purple. So now we have a wire which says purple, and that's gonna be our goal color in this example. However, we need to count with any possible color to be right there. Even no color is possible. There are 7 possible colors in total, not counting the uncolored one. The logic does not allow us to deconstruct colors. So now we are getting the signal purple and we don't know that it's red and blue, which means that in the wires layer we need to code that logic ourselves. This is not gonna be pretty at all, but we need to compare this color to any of the 7 possible colors. It's the only way we're gonna be able to know which color we actually have right now and which colors we need to combine. So we compare purple color to every possible color. Every color should say 0, that's not the same, except for this one, purple. Now we need to convert this information into an RGB combination. So in this case, purple is made from blue and red, which means that we want to say, yes please, we want blue. It's gonna be a 1 for blue, yes to red, and no to green. So each of these signals needs to be split into 3. So in this case of purple, we need something like this. Red, yes, green, no, and blue, yes. Okay, so there was a little issue with the original plan. The wiring was simply too complicated. So what I thought is I would split this analyzer into 3. So here we're just analyzing whether we want red paint or not. So the original logic remains. We need to figure out which color we are currently getting. In this case it's purple. And do we want red for purple? Yes, we want, because purple is red and blue. So here I say true, but we only let that signal through if it's a true one. So in this case we have cyan, that's a 0. Cyan doesn't need red. So in case we wanted cyan, we want to negate that information, because we don't want red when we have cyan, right? Let me just switch it up so you can see better. Cyan signal there. So yes, it is cyan, that's 1 here, and we want to negate it because we don't want red. And we only want to let that 0 signal through if we want cyan, right? So that's a 0 here. And the reason for it is that for, let's say, purple here, we currently have no signal because it's a 0 and we're not letting the signal through. So no signal here, and in the end, these wires we want to combine. So if we combine these wires, they're both 0. But if we were to push this 0 through and this 1 from here and so on, we would get mixed signals. Right, so I removed the transistor from blue here, so it's not blue, therefore we don't want red, but we're negating it here, so we get a 1. And if I were to combine it with this 0, that's a clash of signals. And we for sure don't want that to happen. So that's the reason we have these transistors in place. So only let the signal in sometimes. Now we can connect all the wires together like that, and we've got a signal. Again, this signal is for red paint. So since we're getting purple, the output signal is 1. We want red. Now let's try to test this, whether it actually works, and say we want just yellow. The signal is 1. Why? Because yellow is green and red, so that's correct. Only red, also 1. Only blue, that's a 0. It seems to be working. What if I have unpainted? Let's see. So that's no signal for unpainted. And I think we might be able to work with that. No. You know what? Let's play it safe and add another case for unpainted. I'm gonna copy this part, and this constant signal needs to be no paint. Connected here, so now that's a 1. And for no paint, we don't want red. So negate it here again and put it through. So now no paint here means 0. That's awesome. It seems to be working. Now I'm gonna copy this whole area and have it down here again, but this time that's gonna be green. So we just need to redo this 0-1 logic. White remains still the same, but cyan takes green. So we need to remove this negation. So that's it there, and now we want to do the same thing again, but this time for blue. So now we get the color information right here. That's 101 for purple paint. So yes, red, no green, yes, blue. Now we are finally able to start making the actual factory. The original factory had one key element at the start. We brought in this conveyor belt with all 3 base colors, and we want to sort them. Oh, hang on. We could technically have 3 different conveyor belts as the input. I'm not sure why I did it so dumb last time. Okay, never mind, scratch this. We're gonna have 3 inputs, 1 for each color, and now we can start working with that. So here we have the 3 base colors, and now we want to decide whether we want to let them through or not. For this, we're going to use the filters. And the way this works is that I've connected the red, green and blue wires to these filters. Now let's take a look at the red. This filter is going to let the items through only if the signal says so. So we want red, that's true. Do we want green? False, we don't. So green is going to get spit out from the side, and we can deposit it into a trash can, which means that this conveyor belt is going to be nice and empty. So as currently we're making purple paint, you see that we're only discarding green. Now all we have to do now is use these paint mixers and combine the color. The tricky bit here is that we don't know which colors to combine. So let's say we try to combine all of them. We're gonna get into a point where we are combining empty conveyor belt with a full one, and we're not getting any paint at all, which means we need to be smart about this. And we're gonna need possibly 2 stages of combining, as we need white as well. Or no stages at all for unpainted, no color. An experiment I've made here is using these storage units. Still not sure whether it's gonna be working right, but for now it seems to be doing fine. It's just too slow, so I'm gonna input multiple of those painters, right? So this is the desired output. Now I'm gonna switch the color. I switched it to yellow, and now if we take a look, we're no longer getting blue here, so it's not getting into this storage unit. Is it working or is it stupid? So what I wanted to do here is somehow balance the green on the left side and on the right side. But I didn't have to do it via these storage units, and we're gonna get screwed when we have white. Let me try it just now. White, please. Yeah, so we're getting purple, but it's stuck for the green. I think that's not perhaps the greatest idea. Or maybe another filter. Okay, let's try it. So if we want red, then green is gonna go here. And if we don't want red, green is gonna go here. Okay, let's try that. And then again, we're gonna have to account for white as well. Oh, that could work. Hang on, that's gonna work. Right, so now to feed this an information, that's gonna be, do we have red? If so, go to the right. So this is red, so we want to feed it here, but before we do, we want to negate that there. So if we have red, then we're gonna send these greens to the right. So currently it doesn't make sense as there's no green, but let me say that we have red and green, which is yellow. So let's get yellow, please. Yellow? Yes, that's exactly the desired solution. Red, green, that's yellow. There we go. Now let's see green and blue. That should work the same way. Green and blue is cyan. Cyan, please. And there we go. Do we have red? No, so negate that and go through. Awesome. I'm thinking if we have unpainted, that's gonna be no paint at all. We're not getting anything anyway, so all of this doesn't matter. And we're just gonna skip the painting process later, because there's no way to actually make the gray paint. Now let's try white, because that's not gonna work. And here, yes, there's a pollution right here, so we need to go around that somehow. But how? White means we have red, so we're sending green to the right. I would say that here, with blue, we could say only go through if we don't have green and red at the same time, which means we have white. So if we want white, you go around. Okay, great. That's gonna be it. So let's do it. If we have red and green, that's here. Red and green is this wire. Then go... Okay, and negate that. We want to negate that. So if you have red and green, then you go to the right. That's white. Awesome. And now here, we're gonna need another paint mixing facility. So let's copy this huge thing, slap it down here, and we're gonna feed this conveyor belt to there. And that's making white, alright? That's great. But if we don't want white, then we're gonna have cloggage here, because this conveyor belt is gonna be empty. So if you want it just yellow, you need to cut it off here. I'm gonna do a little cheat and place a belt reader right here. The reader is gonna tell us whether the conveyor belt is flowing or not. So that's this 0 right here, because it's currently not flowing. So if we have a 0 there, then here we want to place a filter and say if it is flowing true, you go straight ahead. Okay, no, not like that. You go straight ahead into there, because we want white, it seems. If not, then you go right, and this is the output paint that we want. I'm going to convert the yellow to here and slap it onto this final output. Now something tedious, just a little. We need to test all of this. Okay, so that's white, that's working just fine. Alright, we're getting white. Now let's say we want red, just red. So only red is going... Okay, I forgot this. I forgot. So we need to figure out how to do the lone colors as well. That's gonna be just in a second. But for now, let's handle the mixing. So not red, green, blue, that we can't do. Yellow. Can we do yellow? So that's red and green. It's right here. And since this conveyor belt is not flowing, it goes around to there. Awesome. Purple? Do we have purple? Okay, we've got blue going. But why to this side? What did I input? That's wrong. What is that? That's... Oh, that's exclusive OR. I didn't want to place that. I wanted a NOT gate. So there, now. This little bug just got fixed. And it's going through. We've got purple. Awesome. Cyan. That's why you need to test every possible combination. Yes, only cyan is working. And let's try unpainted as well. Unpainted, nothing here. That's right. Awesome. Now let's try white again, just in case, to see whether I fixed it. So all three are going, which means that this is going, which means that this is going straight ahead, which means we're getting white. That's great. This signal is not reliable, whether we've got blue here, whether we want white basically. So I think this signal needs to come from the source, from this area. I'm gonna remove this part, and here I'm gonna have another AND gate. Do we have blue and do we have red and green? Yes, we do. Which means that you need to go straight up there into this filter and say that we want white and let it through. I can't believe I've done it. I've actually done it. Well, anyway, now let's fix those lone colors. So I should somehow be able to say we want only red or only green or only blue. At which point I need to go around those painters straight to this output. So how do I do that in a clever way? Because there's an easy way of doing this, right? If these both aren't flowing, then this doesn't need to go into a trash can, but somewhere else, I don't know. I think I'm gonna do the logic here, just so I don't have any more of a mess of wires there. So let's try some logic gates. Now let's focus on red only, alright? So that's red and at the same time not green and not blue. That's what we're trying to do. You know what I could do? Do it a lot more simple and use exclusive OR. That's saying exactly one of those needs to be true. So if I do exclusive OR among all three, so one simple signal. So it's gonna be those two brought to here using a crossing, and here we're gonna have another exclusive OR and again a new wire with a crossing here. So that's a 1 and it shouldn't be a 1. Why is it a 1? Oh, I see, because 1 and 1 means 0, but here we have 0 and 1, which is 1. Not working, not working. Okay, hang on, I need to think about this. It needs to be an AND here, doesn't it? So this here is correct. Only one. Just one of those needs to be true. But what about this? So we're saying false, but we don't know whether we're saying false because they are both 0 or because they are both 1. So that's not gonna work like this. I was never good with those. That's not great. My brain is starting to fry. Okay, so I resigned and I decided to do it the naive way. So for each of the main input signals, I say if the input signal and not another signal and not the last signal, then we have only one. So I have 3 checkers which check if only this is true, then if only this is true, then if only this is true. And then I do OR for all of them, right? So this seems very simple. If this is true and not this, and then not that, then we've got true. So now we've got the output signal here, and what we want to do is, I'm guessing, do another filter right there and say if exactly one is true, then you send it around straight to the destination. I would think that's how that could work, and I'm gonna negate the signal as well so that the filters send it to the right. There, those are these connected, and I think I'm just gonna bring them to this conveyor belt, and I know that they're not gonna be working at the same time, so I think we can allow that to happen. So there, they are all connected. We currently have the red signal, so red is coming through, and the output here is only red. So again, let's go test it. Just red, just green. Okay, hang on, I'm gonna get, those are both blue, not green. So let me try again. Oh, the signal. I must have something wrong here. So I'm getting 0, so that's a 1 here for green only. It's the 1 here. And to check this one, we're saying this and not this and not that. Oh, and that's the green. So that's wrong, that's wrong. So that's the middle wire. This is the top wire, and here we need the bottom wire. So this wiring is incorrect. That should be like that. And now it's working again. This debugging is gonna kill me. That's impossible and insane at the same time. Blue, we've got blue, that should be working. It is working. Now let's try red again for good measure. There's red, that's awesome. We might be in the final stretch. Finally, let's go. Yellow. Yellow is working. We're getting yellow. Purple. We're getting slowly there. And purple. Awesome. Cyan. Let's go, Mr. Cyan. We have to wait a second for that red to go away. And now we should be getting cyan. There it is. Then we've got white. And that's the last one. All three are going. And moment of truth. Yes, we've got white. That's incredible. It's working. Oh, so much pain. Now let's try unpaint it. And yes, we're not getting any paint at all. That's the goal. That's what we wanted. I'm gonna remove this, put this back in. So now we should be getting purple again. That's actually insane. I love it so much. It took me about 2 hours to make this. I understand that this video is a little long, but I felt the need to actually show you what the real process looks like. How a software engineer would think about creating such artificial intelligence. And this indeed is artificial intelligence. Its main property is that it's able to decide on its own what to do, even though I basically told it how to behave. I can't even tell you how relieved I am that this whole thing is working. And look at the progress. The factory itself looks fairly simple and beautiful at the same time. The wiring, not so much. I hate this ending, but these bits I'm really comfortable with. I think they look great. Now let's compare to the original dumb design where I combined these 3 inputs into one, and then this. Okay, that's compact. Come on. Oh, that's so simple. Look how simple that is. White, please. And it's taking a bit for it to adjust, but it's really, really simple. But not that safe, because I'm using those belt readers a lot. And I didn't go that route this time, because I don't think they're safe at all. Well, anyway, leave your thoughts in the comment, and I will see you next time. Belts